Alright, welcome back to the No BS Guide. We got chapter 24 and 24 apparently. 24 and 25. Little error.
Great start.
Great start.
Sums it up.
Let me just, yeah. Still more effort than Diana.
Where we guarantee 80% or better that track is undefeated.
Guaranteed 80.
What the fuck is that?
This is
So,
the coloring.
The color coding.
Okay.
So the morning class words, thanks to Connor. We had the words.
I
So
like it. I like
I labeled it
It's we did lesson.
blue for morning, purple for both, red for PM.
Alright, so red and purple.
Alright, starting off.
On the slide.
We had to organize it.
I like it. I like it.
So the t-test, aka the student t-test, is a ratio that compares two means. So we have one group, for example, on an RCT that's control, and one group that gets baclofen.
Oh my
The
god.
classic baclofen. Basically, you use the t-test because you want to show that the treatment group is actually effective. So it's showing there's a difference between groups, but it also wants to show that there's no variance within the groups, because you want your group A and group B to be like similar.
Mm-hmm.
Like you don't want them to be like different,
So
right?
you want them like C, not like D? Question?
We're
So like difference could be like one group got the baclofen, one group got the control, but then the variance would be like, well, they are all the same, similar levels of spastic type lesion.
yeah. So that's what you want. You want the similar levels of spasticity. But if we come here, this example here, group A here, and B. B is clearly different from group A. So this variability within groups would be kind of shot. So this is an important term, error variance, which is variance that is unexplained by the treatment. So baclofen doesn't explain like this like variation that's going on.
Doesn't explain what, like why one group is wide and one group is
Exactly.
narrow.
Which one's better?
Doesn't matter.
Oh, you just said that.
You just want them to be like the same variability.
Same fatness.
Yeah, we'll get to that.
Wait, I think I have.
So the same fatness basically is the homogeneity, I don't know what the fuck that is, of variance. So it's an assumption in the t-test, and it means equal variance within groups. So this is like not equal variance in D, but C and B, we have equal variance because they're both fat and both skinny here.
I can see that.
Yeah. So larger samples have better chance of showing homogeneity. I'm going for that. Go
Just
for
call
that.
it homo.
Homo of variance. And this test here. Oh, we have a new student. All right. Resuming after I was so rudely interrupted by Hope.
He's gonna watch
Keep
this.
it in,
gonna watch
keep it in.
So basically the way you test if the variances are equal is a test called the Levine's test. I think that's it. Uses the F statistic, and basically
Adam Levine.
if the
What
p-value,
He's testing.
So true.
if the p-value is less than 0.05, then the variances are equal, okay? And like we said before, B and C here indicate equal variances, and D not equal variance. So
Whoa. I thought you want P less than 0.05.
you do.
Oh, because you want equal variance.
You want equal variance. This is testing if your assumption is true.
This is different than the P test.
This is different from the t-test. You basically need this to
No,
be
it's a
true
P
to
value
do.
test. I thought. Is that a thing?
Don't worry about that.
Okay.
Don't worry about that. So we're gonna say,
Thanks, Professor.
Professor P, if you will.
in this example here, the Levine's test, we'll say the L test, is significant, right?
How can you tell that that's 0.05 for that?
Oh wait, not significant. Fuck. Not significant
Well, how can you tell it's not significant?
because their variances are not equal.
Oh.
Boom.
And this
Wish I
would be
had this
significant
word.
if the variances are equal.
What does F statistic mean?
It's just the statistic they use. So like for t-test, you use the t statistic.
Yeah.
For this one, you use an F statistic. Don't worry about it. All right.
I'm up.
This one has a fill in the blank for you guys.
Yeah,
Independent.
She gave out a list that had a fill in the blank.
Who did?
This was on her list, or
No, I did.
you created it.
It's me.
Oh.
It's for the.
Compares
I got it.
connection. I don't really know what you compare.
It compares blanks between two independent groups.
Memes.
Hey,
Dang.
That's why I'm the star student.
star student
Get out of here.
means.
I'm literally sitting right here.
How do I make this shit smaller? Oh. Okay. But it's important when you're comparing these two independent groups that the groups have no connection from repeated measure or matching. Do you guys remember what repeated measure is? It's when, like, your subject is the control.
Mm-hmm.
And that's a repeated measure. So you can't be using this with when your subject is their own control. Moving on. So the top for the unpaired t-test is the difference between means, and then the bottom of the ratio is a standard error of the difference between means.
Are we gonna have to know this formula?
No.
Yeah, you say that now. And then mine's like, which one is the formula for the independent?
no way.
She totally
That
messed
is
with
totally gonna be a question.
I think she might, we'll get to something where I think she might ask something like that. And remember, the bigger the ratio, more likely it is.
Because the X with the hat is always like mean.
Yeah, and then the other one's always standard.
Well, the S is standard.
Yeah, the
And the standard error, which is basically like a variance. Term.
Whoa, there was a lot of stuff on that slide.
yeah, dang, you're going
That's-
fast.
What? Zach needs to be locked in.
Yeah, we-
do it faster, Zach.
Oh, you're making this one.
Oh yeah.
This
How
is
do we
for the
determine?
people. This is Zach's not the average user.
That's true.
Oh.
Other
Cut that out.
He
professors.
can put it on 2 times speed.
Zach can't put it on 2 times speed. That's true. How do we determine if this is significant? This is important. So we compare it to a critical value at a specific level of significance. More of this on the next slide.
Am I blue?
Yep, this is the morning class. So degrees of freedom. Basically each test, so t-test, ANOVA, 2A ANOVA, unpaired t-test, they all have different ways they calculate degrees of freedom. So she's not gonna ask you that. I'm just gonna use an example for the unpaired t-tests here. Just know that degrees of freedom are used to find your critical value.
That's what degrees of freedom is.
Like they're used to find,
Crit.
can't fucking spell.
Oh, that looks good.
I think I can read that. So for example, with the unpaired t-test, each group, since there's 2 groups, would be n minus 1. So in total, it's n minus 2. Don't worry about that. So this we have to worry about. If a study had like 10 participants in total, separated in 2 groups.
You said 20.
Oh, 20.
Oh.
Good catch. Good catch. So it'd be
Wow, you're listening.
10 within each group. In total would be 20. Subtract that by 2, you get 18. And then we just selected.
What's the 2?
Yeah, why are you doing 2?
You don't have to worry about that.
Oh, it's because there's 2 groups.
Is that right?
Yeah, this is for the unpaired t-test. You're not gonna have to do math.
Okay.
But basically, we use this to find this critical value here.
I do remember critical values back in the day.
Because you use that critical
I do.
value to see if this t value, if it's significant. So if the t value is 3, and then we compare it to this critical value of 2.101, that's greater than the critical value. So it's significant, right? And you
So
reject
greater
the null.
value.
Yeah. If it's greater than the critical value, then you can reject the null and your findings are significant. Does that make sense? No.
So if T is greater than... Isn't that what T is?
What?
It says if the T value is greater than point...
So This,
Professor P.
you're lost.
This is tough.
God damn it.
I think I'm getting it. Hold on.
I feel like their example in the textbook was way different than this. I thought it was like you had to find the number that was missing.
You do have to find the critical value with a chart, but she's not gonna make us do that on a quiz.
Yeah, but I don't
So-
get it though.
She might just like give us a critical value, give us like a t value, to be like, are the findings gonna be significant? Like,
But I
is
thought
there?
this all had to do with things that aren't like even
What do you mean?
like it's unpaired, right? So
Unpaired.
it didn't. The two groups are independent of one another. So like, what's even the point of doing this? Like they didn't
True.
if they didn't get the same treatment.
You're asking too deep of questions here. She's not gonna worry about
Pull up the textbook.
No.
textbook. That textbook is thick.
Okay.
Like,
Put it back. Put it back.
This is the most studying we're doing.
this is the most studying, most in depth. You don't 80 for an 80. You don't need to go in depth.
Last time we did the textbook.
We did, but I was unprepared.
What'd you get on the last one?
This is based off.
I got an 80 on the last one.
This is based off the textbook, right?
Zach
Yes.
somehow got an 100 because he's him. All right, the paired t-test. This one's used for repeated measure design. What is that? I just
When the
explained it.
subject is
It's
their
its own control.
Yeah.
I sweir I was listening.
Dang.
Oh, it
so-
says it right
It
there.
says it right there,
Oh,
I
we gotta
didn't
go.
and it determines if the values are significantly different. Once again, so it's just a ratio again, but just notes for repeated measure design used a paired t-test.
What's on the compared to what? Like what are the other ones again?
So
Unpaired.
So there's unpaired and then
this is just general. This is like general.
oh.
And then I got more specific here. Wait. Here.
So yeah, there's unpaired and there's paired.
So this is two independent groups, so that would just be like your classic RCT. Can't fucking spell. I'm losing it. Classic.
Can I get a RTC,
RCT.
random control trial?
Randomized control trial.
Close enough.
We did that. Alright, this is what she might like give you a formula or something. She did this on a quiz before.
This is not me.
Oh my god.
So you
Start
remember how,
memorizing.
no, you don't have to
This
memorize
week
this.
is AIDS.
Just like a statistical
Listen to
hypothesis
Postie's new
for.
song. Sorry.
So you remember null and alternative hypotheses?
Yeah.
So the null's basically always saying there's like they're
Nothing's
equal.
happening.
Nothing's happening. They're the same.
Yeah.
So equal. Then once you bring in like a sign like this or a sign like this, it's the alternative hypothesis. Okay.
Right.
Because she did it on the quiz before where she put up and she was like, which one is the alternative hypothesis? You remember that?
So
And
if
it
it's
was-
not equals, it's alternative. Probably.
basically. Yeah, no, it is. So just be able to
That's
identify
good to
those.
know. I didn't know that.
All right, power and effect size.
Both.
I have this.
Yeah, effect size, right?
Oh yeah.
So there's a lot of different effect sizes. It all depends on the certain.
The fuck is an effect size?
Professor P hasn't gotten to it yet.
Frankly, it just wants to see like how strong the actual effect of the treatment is.
So how effective the treatment
Yeah,
is.
and basically, for the t-test, it uses this way where it uses like
Two
standard
means.
deviation units, huh?
2 means, sorry.
Oh yeah, 2 means. And yeah, I don't think you have to go crazy into this stuff. Just know that there's a test using standard deviation units for t-tests, and basically 0.20 would be 0.2 of standard deviation, 0.5 is standard deviation, it goes up, so obviously more standard deviations, the more of an effect it has.
So
that make sense?
which graphs are like?
So
what are
effect
the
size
graphs?
relates standard deviation.
So this would be like 0.20,
Oh, gotcha.
this would be 0.5.
Oh, I see.
So like we want C.
You see how there's a bigger
Yeah, you
difference
want
between
C.
these guys?
You want to see.
You want C. Like if you're
Because-
giving baclofen, you want spasticity,
Oh.
spasticity to be reduced. I might be a little bit spastic, but
Can you interpret the graph for me, please?
these are just your two groups.
You just did.
Yeah. Thank you.
That's 0.2.
Well, no, I know that, but like, what is it actually saying?
Meaning
then?
like
so
one,
there's a lot of overlap.
one curve is the
Yeah,
Both
but
of
not
them are
that
affected.
different.
yeah,
So there
same
clearly
shit.
is a difference between these groups, but is it that strong of an effect?
Okay.
No.
Probably not.
No. It's
This one's like
small.
meh. Like this is mid,
Mid.
right? Here,
It's like your gains if you do like
him.
Nick's program versus my program.
I wouldn't say that.
Just fucking again.
Jake's program.
Jake's program.
Jake's program.
My program.
Jake's program, which Tofa's currently running. That was a joke, Jake. I don't think he tunes in.
Oh shoot! I forgot you're recording.
It's a good program.
All right, PM class. This is not you, so I don't think you have to worry about it. Basically,
Go back to my phone.
for the t-tests, it's when you compare two means. Anything above 2, use ANOVA, which we're gonna get into, right? And the problem
ANOVA.
that you can run into with using multiple t-tests, let's say in your study, is that you're more likely to commit type 1 error.
T for
Don't
2,
ask why.
Right? T for 2, only compared.
Yeah.
Max 2.
Yeah. Max 2 means,
2 means.
and you're susceptible to type 1 error.
What's that?
Type 1 error.
Yeah.
That you reject.
I can get a fact check.
I can't remember. We can just search it out.
I'll look it up.
What are you trying to find?
Type 1 error is when you reject the null, but the null is true in
Oh, I
reality.
hate
It's like
those.
when you're like, nah, there is something from this study, but there's really not.
Yeah.
Right?
Exactly. That is type 1 error.
It's like, please accept my findings. But
Yeah.
they're not right.
Just like
Do
that.
not-
please.
It's just a blip. It's
Think of the
statistical.
cat emoji. Or not the cat. I was sending Nick cat memes today.
Yeah. It's just a,
You don't send me memes.
it's like when you make a bad decision, like that in reality that's not me.
Oh God, this needs to end.
No, cut that out.
No, leave
Cut
it,
that
leave it. That wasn't me on the phone.
That wasn't me. I blame my frontal 20. I'm not 25 yet. I'm not 25 yet. Let's go. All right.
You guys are little boys. ANOVA.
All right. ANOVA.
Drum roll.
We missed it.
So this
You
is
already
when
said it.
3 or more groups are being compared. Because remember,
So
Is
ANOVA,
it group? Never mind. Yep, it is.
ANOVA is him.
ANOVA is him. Yeah. Remember, 2 groups is t-test. And remember,
T2.
we can scroll
ANOVA
back
and
up
him.
for spaced
Yeah.
repetition. Pair t-test is repeated
This
measure
is
design.
easy. This is easy.
No, I don't even know.
And independent or unpaired would just be
The 2 different names are like throwing me off.
what independent.
Like
Yeah, it's
when-
kind of
when you do an RCT, you have 2 means. You have a control group and you have an experimental group. That's 2 means, right?
Mm-hmm.
Okay.
That's
So
the
if you
t-test.
if you're doing a study with like
3
I don't know.
groups.
yeah, so if you're doing like a what do they call that?
Yeah.
Not meta-analysis, the one right below it. Statistical analysis or something?
systematic review.
review.
Systematic review.
Bang.
Yeah. Where they're looking at multiple studies, multiple means, all that shit. That'd probably be ANOVA, right?
Yeah, they'll use ANOVA.
There.
They have to.
There's your clarification.
All right. Same assumptions as t-tests, including equal variances, that it follows the normal distribution, and we're in interval ratio data. And you remember how I said for the null hypothesis, it's
Is
always
that going to be
equal sign?
important, the interval ratio data?
Probably not. But just know it's an assumption. So remember, null hypothesis has the equal signs. So with ANOVA, you're basically saying all the groups are equal. Everything's the same. That's a null.
All these studies, all these means, they're all proving the same thing.
Yeah. And then the alternative, so HA, would be M1 is not equal to M2, not equal to M3, not equal to M4.
And
Dot,
4.
It's mu.
There you go.
Why did I say that? What's that
Whatever.
called?
MU.
It's you.
It's
but it's
mu.
like called
It's
mu.
mu. Like the Pokemon.
Looks like a U.
It does look like a U.
It's a fun U.
But it's supposed to be an M.
I can
Oh
see
really?
No,
I
can
thought it
see
was a U this whole time.
Nah, yeah, I
It's
can
supposed to
see
be an M,
it. It's a drippy.
like a weird M.
It's a drippy U.
Wait, that's crazy.
I'm like 90% sure it's supposed to be an M.
No, I know.
Well, that makes sense because it's
M
called
for me.
U, but I always thought it was a U this whole time.
Zach's gonna be like losing brain cells
Wait.
listening to us talk about that.
All right.
Aren't you cutting this out? Wait.
No, there's no.
So for ANOVA, ANOVA,
Yes.
3 conditions compared, and we want it, and it's gonna be the same, or same as something. Okay.
So Noel's saying everything's gonna be the same. Group 1 getting back to them is gonna be the same as group getting massage, as group getting tinazine or whatever, another drug.
Okay.
I don't know.
Thanks.
So say you did a study where you did control group, massage, baclofen, and Botox. That's 4 means. Would you use ANOVA?
Yes.
Yes.
It's 3 or more.
Yes.
Boom. Put me up there.
You just learned that.
But we're gonna get specific now. We're gonna get specific now.
Okay.
One way to ANOVA.
So
Well,
this is when involves 1 independent variables, but 3 or more levels. So
Yeah, I
we
didn't
can
know what that
have caffeine
You got so happy.
at 100 milligrams, 200 milligrams, or 300 milligrams. Okay, 3 levels.
okay.
But since we have 3 levels, we need an ANOVA.
I like it.
Yep. Use F statistic, and
Ugh.
if it's greater than the critical value, we reject the null. Right? It's the same concept as the t-test.
Greater than the critical value, reject the null.
Reject the null, because you're showing that it makes a difference. I wouldn't worry
when
about
you think you're great, they think they're greater than them, and they reject them.
What's the
You're the
null?
null.
Yeah. Yeah. That
If someone thinks that they're greater than you, they're gonna reject you.
Don't look at me.
Life lesson from ANOVA.
But what's the null?
You are the null. No, not you, but just like in my example.
Because I rejected you.
Yeah.
Get pitched.
It's getting edited.
No, keep it in.
power and effect size for this, they
It's
use
you.
these. She's not gonna ask us how to do the math and all that. So just
she
know this.
surprises us.
Just know this. I'm pulling a Zach.
Wait.
Hey, Zach.
1 way ANOVA.
Who is this being sent to?
This.
It's just on YouTube. Explain this, Professor.
I frankly.
Wait. 2 forms of effect size.
It's how effective the treatment is,
With the
effect
one-way
size.
ETA squared.
To figure out how effective the treatment is, they like use
If I'm
these
doing
numbers.
math tomorrow,
You're not doing
I'm
math.
leaving.
That's why I'm not going in depth on
Oh.
these concepts. Because she's not gonna make us do
Yeah,
math.
no. She definitely is.
2 way
Is
ANOVA.
that gonna be a question?
This.
Wait, go up. Okay.
She could be like, what tests are used to figure out or which test is used to figure out the effect size in 1 way ANOVA, and we'd have to select this or something. Do I think it's a high possibility question?
Yes.
No.
Oh.
No.
It's definitely on there.
So yeah, for sure. I'm gonna see Cohen's F and I'm gonna be like, dang it.
I don't think she'll ask that question.
So it's 2A, yeah. 2A.
Here's something I think she'll ask. She'll give us like a study, and there'll be 2 factors. So we'll say caffeine.
That was a good example. How'd you come up with that before? So fast.
Cook.
You did.
Just off the dome. What's another stimulant?
Oh, okay. I
Adderall.
spoke too soon.
Math.
Adderall. With 3 levels. So we do the
You guys are good at
DMA or DNA.
100, 200,
DNA.
No, DMA.
300,
DNR.
10 mgs, 20, 30. So 2 factors, but they all have 3 levels, right? This is 2x3 design. So we would use a 2-way ANOVA.
Makes sense.
Okay. And for this 2-way
Does it have
ANOVA,
to be 3 levels or could it be
3
like
or
2?
more.
Could it be?
it can be more than that level. It can be like 4 or 5.
What if it was like caffeine 100, caffeine 200, Adderall 10, Adderall 20?
No. Is
That could work.
You said 3 or more.
No. That technically would work.
It would work.
Yeah.
Unsure.
Because the levels add. It's strange. You don't have to go deep into like the math. It would work.
Okay.
All right. Repeated measures ANOVA. Just know this is ANOVA used with repeated measures design.
Which is the subject is their own control.
Yeah. And just know that.
That's easy.
Why
Wait, what was
there's
it?
no smiley face.
Because she didn't put this on any specific quiz for the vocab quizzes, but this is something she can ask in like the second quiz with your group. Mixed ANOVA uses one independent factor and like one repeated factor. Don't ask me how. It's basically like a mix of the repeated measure and the normal ANOVA.
Mm-hmm.
Mix thinks you're mixing both of them. ANOVA.
That's not how I was gonna say it.
I was wondering what the fuck ANOVA was.
Analysis of
I do.
covariance. This is basically, in your studies, you get your groups, and then you'll get like covariance, they call them, or like, I can't think
Is that supposed to say covariance
where.
Covariates.
or covariance?
Probably covariance.
Covariates. Isn't that?
Or covariates?
Typo,
I don't know.
typo.
Covariates? I don't think it matters. You guys know. Just so an example for this, I need an example. To
Yeah,
like
it's
figure out.
covariance.
Oh,
Good
well, I'm
catch.
not saying that.
Variance. Like
So-
variance is a key word. Variance.
We use the example here. If a patient's wearing
He does not
orthosis,
care.
Do not
orthosis A, and they happen to be taller,
start over.
that's a covariant.
He's just reading the sentence.
Can you start over again, please? I was caught up on the
If the
spelling.
patient's wearing orthosis.
Just think about
Orthosis.
covariance like confounding factors,
Okay.
and you're trying to eliminate them. You're trying to make them equal within groups.
Oh wait, we already had this as a word.
Exactly. And if the patients are wearing orthosis A, and they happen to be taller, that's a confounding factor.
It's taking into account like if you're doing a hypertrophy program or a strength program, and you're analyzing women versus men and how much they can add.
it's like
bench
giving
press.
a woman like testosterone.
Take into effect that I thought it was like taking into effect that one group's women and one group's men. Like men are probably going to build more mass than women. So
Well, yeah, so you adjust for that.
that's ANOVA, no?
Yeah.
Dang, he didn't like that.
No, it was actually good. That was good. And they happen to be taller, so the ANOVA can be used to predict what the step length for the group that was like shorter. What would they be if they're like taller, kind of? It just equals out the confounding factors. Okay? That's all you gotta know.
At the end.
That's it.
Okay, perfect.
If you wanna
Explain
not
that
go-
one. Explain that one.
Due to the difficult content this week, we are not guaranteeing you an 80. I'm guaranteeing you a solid 6 out of 10 or 60.
70.
We'll take it.
We'll take it.